We're now going to be taking a look at factorising quadratics, and the example we're going to consider is x squared plus 3x plus 2. Now, so far we have looked at factorising in this section, and we have looked at factoring out some terms and getting it into a form of something out the front of the bracket, and then the bracket itself with the other bits in. And we've looked at the terms and said, right, this term, this term, and this term, they all have these common factors, and we can factor them out. However, when we look at this, we'd be going, well, we've got x squared, we've got 3x plus 2. These three terms don't really have anything in common, apart from one, that I would be able to factor out. So how can I go any further from here? So in order to understand how we're going to do this, we really need to know what our target is. Okay, so the idea is that we should be able to get it into a form of x plus p, x plus q, okay, where the p and the q are things that we want to work out, okay, they are the unknowns that we want to figure. Now this is strange. Well, this looks, we've looked at expanding brackets, so we know that we could, if we had something like this, we would be able to multiply the brackets out to get it to this form. But how do we get from there back to this? So it is this that is the target. This is what we want to get to. So what we're going to do is we're going to expand this out so we can see how we can then factorise this into that form. Okay? Now, you will likely have been taught a method of how to do this at school, of looking at or trying to find two numbers that multiply together to make the plus 2 and add together to make the plus 3. Okay? What I'm going to explain here is why you're doing that. So we're going to expand this out, okay, and the p and the q are what we want to find. So we're going to have x times x, which is x squared. We're going to have x times the q, so q lots of x. We're going to have p times the x, so p lots of x, and then we're going to have p times the q, so p q. Now, focusing in on those two middle terms, those two terms can themselves be factorised, can't they? Because they both have a common term of the x, or the common factor of the x, I should say. They both have an x. So, I would be able to write that as factoring out the x, and I'm going to write them in alphabetical order, so we're going to have p then q. So p plus q times x plus the pq. That's on the end. So those bits have stayed the same. The bit that's in the middle, that has been factorised. So now what we're going to do is we're going to compare this with this. Now the x squareds are the same, okay, so they're both the same. The p plus q that is in front of the x must therefore, if they were to be the same, must be the 3. So the p plus q must be 3. And so that bit's the 3. And the bit that's on the end, the plus pq, that must be the 2. So this bit has to be the 2. Now, in the grand scheme of things, you might be then looking at these going, well, actually, this is some simultaneous equations to solve. But the way that we do it when we're taught how to do this is to try and come up with the two numbers, because the actual solving of those two equations, it can be done, and those of you doing higher GCSE maths should be able to solve these simultaneous equations. But at the stage that we're at, we're just going to look at the two equations and go, can we figure out what the numbers would be? And this is the idea. We're looking for two numbers that add together to make 3. And we're looking for the two numbers that multiply together to make 2. So we need to add together to make 3, multiply together to make 2. Can we think of any numbers that do that? So that's our job here, okay? And you may be able to think of those two numbers, and that would be, well, P and Q could be 1 and 2. Because 1 plus 2 makes the 3, and 1 times 2 makes the 2. So P equals 1, Q equals 2. Okay? You could have had those the other way around as well. So you could have had P is 2 and Q is 1. Okay? It wouldn't matter. So now we have the P and the Q that we need. This can then factorize to x plus 1, x plus 2. And this is now in factorized form. Okay? So, what we want to do is we want to look at the two numbers that are the coefficient of x. Let's get rid of that as well. Okay? So we want the two numbers that are the coefficient of x. We want two numbers that add together to make the 3, but multiply together to make the 2. And I now have it in factorized form. So let's take a look at another example. Let's say I had x squared plus 9x plus 20. Okay? So what we're looking for are two numbers that multiply together to make 20, but add together to make 9. Okay? So, two numbers that multiply to make 20, and you could write it out like this if it helps, but add together to make 9. And you might go, oh, well, that's 4 and 5. Okay, so that allows us to write this as x plus 4, x plus 5. Okay, and so that is what we're looking to do here. All that bit with the P and the Q is justifying what we're doing. Okay, so you don't need to be able to replicate that. The idea is that we need to be able to go from this expression to that in one go if we can.